guys, welcome to Bar Z. My name's Stan, and welcome to part 2 of the argon for your hotshot. Today we're going to look at the test results, and we're going to pull some parts. We're going to drop them in oil, do some hardness tests, look at the scale buildup with and without argon. And I'm doing this all basically for people that have requested it. A bunch of people said, hey, why don't you put argon in there, or nitrogen or something like that. So I had some argon here, so I thought I'd try it. It doesn't really matter to me. All the parts that I make hit the surface grinder anyway, so I don't really care whether they get scale on them. But I'm doing it for you guys. You know, a lot of you guys are messing around with the stainless steel wrap, and maybe we can get away from that. We don't know. Let's take a look at some of our results. Here we go. Well, they look pretty clean. And that's all there is to it, boys. Okay, that was a 27-second quench. And the parts are fairly clean. They got a little bit of scale on them. Let's get them dried off, and we're going to check them. Usually they go straight into temper, but we're going to check them here before they go to temper and see how clean we kept them. And then we're going to harden a set of parts with no argon, and that way we can look at the difference. All right? But they're fairly clean, so I haven't done anything to these except put soap and water to them and clean them. We're going to take a test block. We're going to check hardness now. See, make sure they made hardness. This is a 60 block, 60 Rockwell, and there we are. So we are calibrated. We verified our calibration, and let's see how hard these turkeys got. We can check them in a couple places. 61, that's pretty much what I'm used to seeing with 01 as hardened. We're going to draw them back to about 58. There's a 62. Let's try it in one more spot over here. There's a 59. Check these other ones. So 60. About a 62, and that's why you want to temper them, to get them, to draw them back and get them back into a softer state and get them more stable. They'll come in real stable at 58. But that's the scaling I got, and that could all probably just be polished off with Scotch-Brite. I haven't tried. So let's do a set with no argon and see how they turned out, so we can side by side these things. Okay, tomorrow is now today. I actually ran out of time yesterday. Here we are running the same profile. 2-hour ramp up and a 20-minute soak, 1500 degrees. And the only difference this time is no argon. So bottle's off. And we've got one single pair of squares in there, sitting in the exact same spot. And here's yesterday's. And I went ahead and took them to the sink, polished them up with some Scotch-Brite and degreaser. Okay. Those have still not been tempered. So I'm breaking my regular chain of events. Anyways, those are 1 CFH argon. We'll get the next set out here. And just with a simple cleaning of the sink, we'll compare them, see how much scale we got. Here's something interesting. This is the nickel I used to, wire the two pieces together. Now, this went through everything that the squares went through, but this is the same material that your heating element is made of in your oven. So these got quenched, these got taken up to temperature. and now they are glass hard. So that's what happens to your element in your oven. I just thought I'd demonstrate that, how brittle nickel can become. That was very malleable when I first wired those squares together, but they become glass hard. So that's just a warning. If you harden the element in your oven, it does become very fragile. Okay, well that snuck up on me. That's why they got an alarm. I wasn't paying attention, wasn't really ready for it, but here, let's get gloved up. And get ready to pull here. I wasn't even ready for this at all. This is no argon. This is just straight squares. Okay, we will see how these stack up against the other ones. Let them drip a little bit. I'll hold them in front of the camera and let you see what they look like straight out of Quench. Get them a little closer. That's what they look like straight out of Quench. So they're going to be a little scaly. All right, let's get them at least clean, then we'll do a side by side. Okay, here's our argon parts. As they came out of temper, they got that nice golden color. These were tempered at 375 for 1 hour. And this should have brought us down in hardness. If you recall, we were up in the low 60s. We should be down in the high 50s now. There's 58. Let's try the other one here. 58. And that's the thing about tempering. It puts you down and gets you nice and consistent. 59. So you got real predictable results. You know, just from the temper. The tempering's a pretty important step. So anyways, those are argon. Let me go pull the other ones, our non-argon models out of the tempering oven. Okay, we got our two sample pieces here. This was 1 cubic foot an hour of argon. My final results, these have both been through temper now. You see they got kind of that golden color. These made 58 Rockwell C. I went ahead and showed that. I was worried about these making it. This one's no argon. We hit our numbers again, 58 Rockwell C. But you can, I'm going to pull them up in the camera and let you take a good look at the scaling. These all have the exact same surface treatment in the sink with Scotch-Brite. And I'm showing you the scaling there. Let's look at the other ones. When it did scale, when you get these little pieces of scale on there, they are very hard. It's just glass hard. But you can still see the machine marks, the mill marks in this one. Okay, well, I got a really big batch in the oven right now with a real heavy argon flow just for testing, and I've made a couple of small changes. Let's go take a look at that. Well, the rest of my tray of parts is empty now. There's our first two test subjects there. All the rest of them are in there, all in one shot. We're ramping up. I set this cycle to 1550. I gave it an extra 50 degrees. We're still using 120 minutes to ramp up, and we're still using a 20-minute soak time. Um, we are flowing pretty heavy argon. So I'm flowing about 10 cubic feet an hour of argon in there. So it's a pretty heavy argon flow. And what I did different inside is I've got them up on a kind of a table. I made a table out of soft brick with 4 little legs to kind of elevate it. And so the argon could flow around and the heat would have more better circulation underneath the parts. So we did a few things different. Kind of elevated the parts up in the oven. I don't want to open the oven because it is an argon environment. That's the whole thing. You're just curiosity killed the cat. So we need to keep this thing closed till we're ready to pull. All right, I'll bring you back and I'll go ahead and film the quench and take a look at those. See if an entire batch can stay clean. Okay, we're back at it. Back to the gloves, back to the face shield. Now, this is an argon environment, but I do have a wire sticking out there. The oven's de-energized, I'm safe to go in, but this is a really big batch. Oh yeah. Look at that brick in there. Can you see that circle on the brick that I got inside of there? That's the argon blowing in. Okay, that is a very large batch of squares. They do like a flash. As soon as the oxygen hits them, they do like a flash scaling, but it just peels right off. Okay, well, our parts have been cleaned, and we can get a good look at them now. The scale, like I said, the scale just kind of wipes right off. You still left with discoloration. That's going to be the norm. But the scale buildup, what happened? They as soon as the oxygen hits them, they flash scale, and then you get them in oil right away, and then whatever scales on them just kind of rinses right away. So I left them on this piece of wire and just just kind of rubbed them with my hands and let the water run over them. But here, I'll show you the difference between. There's an argon. It's still a little wet, but there's an argon. Pretty clean. And here's a set. No argon. Right next to it. So you can definitely see the difference. Okay, here's part of our test group. This one is 10 cubic feet an hour of argon. Came in at 58 Rockwell after doing a 375 temper. This one is no argon, 58 Rockwell. That is scaling that will not come off with Scotch-Brite. Everything else has been clean with just red Scotch-Brite in the sink. This is 1 CFH of argon. Came in at 58 Rockwell, so I'm still hitting my hardening numbers. There is some scale on there. You can see that it would not come off down in that groove. So those are the 3 samples. Here's a couple others out of the large batch. And those have not been Scotch-Brited. They've just been rinsed. This one here has been scrubbed with Scotch-Brite. You can probably see the scratch marks in it from scrubbing it. All right, so those are your test results, and that is our test group. Okay, we're back to the hardness tester, and these are the squares from our our big batch. And my only differential with these was heavy argon flow and elevate the parts. And I added an extra 50 degrees just to kind of keep up with that extra cold argon coming in. So that's why I thought the extra 50 degrees wouldn't hurt anything. 58. These are the numbers I'm looking for. That's 59. Let's flip it. Get one over here. 58. Do this other one. 58. $59. Okay. All right, guys. That wraps up these experiments. That's how clean your parts are capable of coming out. Okay, let's see how this fitting held up. I've done 2 cycles with no argon and 2 cycles with argon. Well, it's discolored. You can see the purpley color on there. So it definitely got hot. It didn't turn black. It didn't start burning it up. So, and it's still pretty warm. I mean, the oven's it's cooling off now. The oven's at 650, you know. So final thoughts on this is to make this probe so it just drops in and snaps in with the hose attached, and you take it out when you don't need it and just screw some kind of plug in there or something, so that in the non-argon times you're not sitting there burning this thing up, because eventually that's going to get damaged with no argon flowing through it. Remember, if we're flowing argon through it, we're cooling it. But the times you don't flow argon through it, you're probably going to damage this. So those are my final thoughts. Okay, guys, I hope you enjoyed this little 2-part series of adding argon to your hotshot, or any other oven for that matter. You know, I've shared all my insight and what I think needs to happen. I'd like to hear some feedback from you guys and see some testing out in the field. You know, what are your results? What are you experiencing? All right, let me know. Thanks.